We're going to make some basic cross-product calculations here, but everything we do after cross-product, the calculations will depend on these. The first thing I want to write down, just to make sure that we know it, is that U cross V is not the same thing as V cross U. Now, notice, by the way, they have the same length because the length of U cross V is just the area of the parallelogram formed by U and V. Well, that describes the same length as V cross U. They are both perpendicular to U and V simultaneously. The problem is, if you do U cross V so that you put your right arm on U so that your right hand curls toward V, your thumb will point in the opposite direction, and then if you put your right arm on V and let your right hand curl towards U. So we get this automatically, and that's a good thing to remember. This is actually called anti-commutative, right? Dot product was commutative, cross product is not, right? Let's just do a couple of nice, easy calculations. Let's look at I cross I first. Well, let's talk about the length of I cross I. We should be able to talk about the direction. We should be able to talk about its length. Well, how do I calculate the length of I cross I? I'm supposed to draw I. Well, I is a unit vector in the x direction. The other I is the same one, and the length of I cross I is supposed to be the area of the parallelogram they form. Well, you can see the area of the parallelogram they form has area 0. That's a degenerate parallelogram. However, there's only one vector of length 0, and that's the 0 vector. So we get right away that I cross I is a 0 vector, because its length is 0, and there's only one vector of length 0. Now this is also going to apply to J cross J, because its length is equal to the parallelogram formed by J and J, and that would be 0, and there's only one vector of length 0, and that's the 0 vector. Same thing for K cross K. The length of K cross K should be the area of the parallelogram formed by K and K. The area is 0, and there's only one vector of length 0. So we get that I cross I is a 0 vector, J cross J is a 0 vector, K cross K is a 0 vector. So far, cross product is really boring. All right. Let's start doing one with another. Let's do I cross J. This is easier in a room, but we can try this, right? So what I'm going to do is I'm going to put our normal x-axis there, our normal y-axis there. Now if you do this, by the way, correctly, the positive z-axis points straight up out of the board. We're going to need that actually in just a second. And here we go. What am I supposed to do? Let's find out how long I cross J is first before we worry about the direction. How long is I cross J? Well, the way we measure lengths of cross product is we make the little parallelogram that they form. I is one unit in this direction, J is one unit in that direction, and they're perpendicular to each other. When we draw the parallelogram, we get the unit square. The unit square has area 1, so the length of I cross J is also 1, because that's the definition. Now what about the direction? What am I supposed to do? I'm supposed to put my right arm on I so that my fingers curl towards J, and then my thumb is pointing in the correct direction. You can see that my thumb, by the way, right now is pointing directly up. And as we started this discussion with, directly up was in the positive z direction. So the direction is going to be in the positive z direction, because my thumb said so. And so does yours. So we have to ask ourselves, what vector has length 1 and is pointed directly in the positive z direction? Well, that's our definition of K, right? So these two things determine that the vector I cross J must be the vector K, because it has to be length 1 and it has to be pointing in the positive z direction because our right thumb said so. So that's the first thing we want to worry about. The second thing we want to do is, how about J cross K? Well, this shouldn't be too much different. We're going to have to worry about the picture a little teeny bit, right? Normally, J goes over here, and K goes up like this, and then I, or the positive z-axis actually, points in that direction. And the question is, if I rotate this picture so that J and K are on the bottom, then X points directly up. In other words, if this is J and this is K, and by the way, notice that we're going counterclockwise from J to K, right? And the fingers of my right hand, right, would point in the right direction, right? Then the direction of J cross K would be directly up. But if you rotate this picture, that's in the positive X direction. In other words, if I look at J cross K, it's length 1 and it points in the positive X direction. Well, there's only one vector that has length 1 and points in the positive X direction, and that's the vector I, like that. The vector K cross I is no different. If you're thinking alphabetically, that's not the way we want to go, right? And again, how would this work, right? K points this way. I points this way, right? If you rotate this, right, to look at it so that it goes like that, you can see that the positive y-axis is going to be the one that's pointing up. In other words, I'm scratching my desk to death here. If I just rotate this, now if I'm just rotating, I'm not changing the orientation between the vectors, right? If I rotate this, right, K is going to go this way, I is going to go this way. If you don't trust me, by the way, go stick your arm in the corner and watch what happens. Positive J winds up being just like that. So K cross I has length 1. And again, why? Because when you look at the little parallelogram has length 1. The direction of K cross I is in the positive J direction because our thumb said so. Right? And you're going to get positive J. So that's actually the right way to think of it. The way people remember this usually is something like they'll put a little I here, and they'll put a little J here, and they'll put a little K here, and then just put arrows between them. The arrows are not vectors. If we draw this bigger so we can actually read it, right? So to remember. I can spell remember, even on a bad day. What we're going to do is just put a symbol for vector I up there, a symbol for vector J there, a symbol for vector K there, and just draw an arrow from J to K, an arrow from K to I, and an arrow from I to J. And then the way they remember it is they'll say I cross J is K, J cross K is I, K cross I is J. Now if you go against the arrows, it's negative. So J cross I is minus K, I cross K is minus J, K cross J is minus I. So this is just a little mnemonic to actually help us keep them straight. But those are the easy ones. I do have you actually draw a slightly more complicated parallelogram, but the answer is very, very similar. And before we get the distributive law, this is all we can do. But if we have the distributive law, we can actually do the whole thing, which is really, really cool. And that's actually one of the activities, is if we have the distributive law, it's going to be a big, long mess, and we'll try to make sense of it. But we can actually do the cross product of any two vectors as long as we have the distributive law.